Okay, here we go. Just want to say immediately, I have no idea if the audio quality is good here because I completely changed my streaming setup. So let me know if anything's too loud or if maybe the microphone is worse than it usually is. Oh, that's interesting. We actually have 1440p resolution now. Cool. Yeah, no, so I completely switched my streaming setup, so I don't know if the music is too quiet or if the microphone is too loud. And also, I have no idea if the overlays are properly working or not. But yeah, so I'm gonna be working on Jolt physics again. Assuming everything's stable. So I'm basically currently working on redoing the collider system a bit, purely because I wanted to work a bit nicer with Jolt, because currently it's completely designed for physics, which I don't think the way physics and Jolt handles colliders is very different. And if I adapt this to be a bit more friendly for Jolt, we can actually get some better performance from it. So I've added this compound collider component, which is basically just a way for us to say that a certain number of colliders belongs to a given ragdoll. No, not ragdoll. Rigid body. So Jolt basically has what it's calling compounded colliders, which is it's a collision shape that just stores other collision shapes in a more efficient way. So you can take multiple collision shapes and kind of compound them into a single data structure, which I think lets Jolt optimize the kind of collision checking a bit. And you can also mark them as immutable, so they won't, like, you can tell it that they're not gonna change, and that lets it do even more optimizations. Marka, what's up? Is the audio good? Because I have no idea. I haven't had time to test it. Okay, did that appear? Yes, it did. Good. Okay. The stream alerts is working, even though I need to adjust the name on the follow alert. Got her as quick as I could. Yeah. But yeah, actually I got Jolt finally, simulating properly. So you can see this is running with Jolt, and we can now simulate it. It was me who had just done something wrong with Hazel's code. I don't know if it's faster yet. I haven't done any kind of testing to see if it's actually faster. I guess we could. I should probably add a way to kind of restart the entire engine using the other physics API without having to shut down. I should probably add. So if I wanted to do some profiling here, I would have to do it in simulate. So I can probably just add, what's it called? Profile scope. Profile func. Is that it? The one that uses optic. Yes, I think it's profile func that we want in that case. Simulate. Do I not have? I'm fine, okay. Debug? Yep. Let's add this into physics scene as well. Now, obviously, I've commented out stuff that isn't used. And also the way we currently do the physics simulation is a bit different because we do use substepping. But I think it's still going to be an accurate profiling because Jolt obviously expects me to update it in a different way compared to physics. So I don't think that should factor in too much. Although we would probably want substepping for Jolt as well. Let's do the profiling, and then after that I'm probably gonna start rewriting the way we handle colliders. Because Jolt expects me to handle colliders very differently from physics. Because it wants me to provide everything. All of the colliders would preferably be provided at the moment I create a rigid body. Whereas physics just lets you dynamically add as many shapes as you want afterwards. But I think Jolt can potentially optimize some stuff. Also, I don't know how I suddenly managed to get 1440p working on Twitch. Because I tried to get 1440p resolution going when I was using Streamlabs, and it just refused to give it to me. Even though like I changed the bitrate, I changed the resolution and everything. But now when I'm using OBS, it just works. Interestingly enough. Physics test. And let's do, what do we have? Optic. Yeah, we have optic. Yeah, you have 1440p. That's the thing. I have been trying to get 1440p like working for like 2 months and just hasn't been working with Streamlabs. I switched to OBS Studio, set everything up in the same way but changed the kind of output resolution, and all of a sudden I have 1440p, whereas the same thing in Streamlabs did nothing. It was still 1080p. Okay, so let's connect up, hit simulate. This is using physics. Yeah, OBS is way better. Like, obviously Streamlabs has, you know, integrated support for overlays and widgets and that kind of stuff, but Stream Elements is that I'm using now seems fine. But why aren't they colliding? Okay, so physics doesn't let me collide stuff together for some reason. Are we not creating rigid bodies or like static entities. We do this. Or are we not adding the shapes or something? Not current scene. Physics scene. We do this. Yeah. I don't know why it's not colliding. Let's go into physics. Readability, we do create a static actor here, which does that. Okay. Creates the actor. We don't do attach shape with a box shape, which does that. Is it because I'm not setting the simulation filter data? Because that's gonna be annoying. That could be what's happening here. Okay. Let's do this real quick. Just to verify that the colliders actually exist and look correct. Also, I don't know if I said thank you to Firefly Moth for following. I think I was too busy checking if the notification got through. Are we debugging? Not yet. Am I not in debug mode? Yes, I am, but I don't have the debugger. The debugging option. Ah. Okay. I'll do this instead. If the page should debug API, good. I don't have a way of getting the debugger. Grab that. Start debugging. I want the debug to network. There we go. Where are we including the where? Okay. Now it should work. Let's maybe change the music. Still not happy. Because Ah, crap. Yeah. I can't include it in physics API. Let's just forward declare it. There we go. Okay, now we should be able to debug it properly now. I will say the one thing that I not like, one of the downsides of Jolt is it doesn't have anything like a debugger like physics has. So debugging the actual physics is going to be a bit more annoying, I think. So it's a static. It does in fact have a shape, so I think it is simply because we're not setting the filter data, is all. Yeah. That's exactly what's happening here. Because of the fact that we're not setting that, the filter shader is never gonna return this. For now, I could just say like return default. If I didn't want to go through and actually properly set up the filter data, how much work would that be? Because it's similar to what we do in Jolt, except Jolt actually has proper layering. Thank you. Why is it so slow? That was surprisingly slow. So where is it? Physics shapes. Okay, what's going on here? Ah. Just open up. Regular Hazel. Can't be bothering with GitLab being slow. So, thank you. Physics shapes. So I have set filter data here. I'm sorry. What? Visual assist not being very helpful right now. Physics actor. I think this is where we build the simulation data either way, or the simulation filter data. Yes. Based on the current layer. So let's maybe steal that for now. In here. And we only do that for dynamic actors. No, we do that for all of them. Because it's per shape. So in that case, we can just go up here. And the data is that. And then when we attach the shape is where we set it. So if we go to add collider, we do that. That then, I assume, sets it immediately. It does. I would suggest maybe doing this. Set simulation filter data. Get the data. Let's try that. Now it shouldn't have any problems whatsoever. And it doesn't. Good. Let's profile it. Yes, yes. I wonder when Hazel gets a proper loading screen. I don't know. When someone has like a day to spare on something like that. I mean, it wouldn't be hard to implement. But also it's kind of pointless right now. It's not super important. Maybe before we like make a release of Hazel, not sure. We probably want to have something like that. What kind of church music is this? Oh, it's literally called prayer. Okay. Okay. I'm actually really interested to see which physics API performs better just with this like basic test. Because obviously it's nothing complex. None of the physics API is gonna struggle with like what 20, 30 cube colliders. But it's still going to be kind of interesting to see. Let's hook that up. Probably should have done this before. No, physics. This one. And this is physics. So we do that. Stop. Okay. So where do we have can I do like a Control F? One millisecond. That could be because of the fixed time step though. Maybe. .3, so maybe it was a particularly bad frame. 0.39, 0.29. Okay, so it seems to get worse the further along in the simulation we go. Except for this frame, when it did nothing. And then we get this 1 millisecond, 1.1. Yeah, this timing is all over the place, it seems, for physics. Let's say that out. Just call it physics simulation. Then let's trash it and switch over to Jolt. That's actually really interesting that it was kind of not consistent across the entire frame. Well, across all frames. So this is Jolt. There we have it. Let's connect. Hit simulate. Stop. Stop. Okay, let's search for Jolt. 0.3. Alright. Is this the first one? I think so. 0.1, 0.14, 0.14, 0.12, 0.17. Okay, so Jolt is definitely more consistent. Because in physics we had that 1 millisecond spike. And I'm wondering if that's when the actual collision happened. Because I can't see like a spike. Well, 0.2. 0.1. Yeah. So Jolt seems more consistent. Definitely. Which is good. So just that basic test, Jolt is definitely the more consistent in terms of the performance. At least for something as simple as just a bunch of cubes falling. It's kind of weird to see physics jump up to 1 millisecond for, let's face it, a bunch of boxes. That's weird. But yeah, so I'm gonna start working on, so Jolt might be better. Yeah, like I definitely think Jolt can, I think it has the potential to achieve much better performance than physics. Because it's designed, first of all, it's written in modern C++, whereas physics is very old. There's a lot of old code in there. Secondly, Jolt is, I make the comparison that Jolt is sort of to physics what Vulkan is to OpenGL, right? So Jolt requires you to be more upfront with what you want and what you need, right? So you have to allocate stuff beforehand. You have to tell it like you have to tell it more stuff in more detail before you even begin simulating. Whereas physics just dynamically allocates whatever you need during the simulation, which can obviously result in slowdowns. And I think Jolt also has the potential to optimize things a lot more. It can optimize colliders in a very nice way. If you have multiple colliders, you can mark them as immutable, so Jolt can optimize things based on that. Just from what I've read, it does seem to be capable of optimizing things a lot more than physics can. Which is why I'm kind of going to redesign the collider system a bit to be more targeted towards Jolt, including this compound collider component. And what this will do is it will take it lets you group a bunch of colliders into a single actor, right? So, if I just run this real quick, we can take a look at what I kind of want to do with it. Let's switch the music there. So if I were to go into physics test, and if we take a look at, for example, this hoop, right? Currently it's made up of 5 static actors and 5 colliders, right? And in physics, you could say that this is the actor and it has all 5 colliders. In Jolt, I can say that this pole, the kind of main object, can have a compound collider. I can say include child colliders and mark it as immutable. And what I can do with that is basically go and construct a Jolt compound collider, which is an actual data structure that just takes in a bunch of collision shapes and stores them in a more optimized way. which also reduces the number of static actors that we need in the seed. So that's what I'm going to be doing, and we can see we can include child colliders, which will tell it that all of these box colliders belong to this static actor, right? Which means we don't have to create any static actors for these entities, which saves memory. And we can also say that it's immutable, meaning we cannot add or remove colliders at runtime, which lets Jolt do some optimizations based on that. We can also mark the actual colliders themselves as immutable as well, which again, you can't do any of that in PhysX, which is, I think, this system allows it to optimize things a lot. So, okay, let's see, did I add these to the serialization compound? No, I didn't. So let's make sure we're serializing. Why does Epidemic Sound have a song called Bubble Wrappings? I'm trying to find a good playlist here. Let's go with this one. And yeah, I think that is actually great, because it first of all forces us to kind of write our code a bit better and make it a bit more safe. Plus it allows for some really good optimizations. And obviously this one wouldn't technically do anything in PhysX, although we could make it do kind of something similar to what Jolt does. What's that? Child colliders. So far I am very impressed with Jolt's kind of architecture. Okay. It's immutable. Whoa. Can YAML deserialize vectors? Is my question. I have no idea if this can actually deserialize vectors. I assume it can. It makes sense that it would. And apparently it can. Good. Okay, so inside of, I think it's Jolt. Well, this is gonna happen in a few steps. So first of all, we're gonna check here. And the interesting thing with Jolt is you can't create a physics body without a shape. It requires a shape when you create it. So in Jolt scene, on a create rigid body, we can actually immediately check if the entity doesn't have any colliders. And if it doesn't, then we don't return. Then we don't create an actor at all. Doesn't have a compound. If it doesn't have a box collider, doesn't have a sphere collider, if it doesn't have a capsule, I should probably make its own function for this, but box, sphere, capsule, mesh collider. Don't know for it. Couldn't I technically create a template thing here? Because I think that's done in the game engine series now. So I can check, does not have like any collider or all collider or whatever. Let's try now. Hazel. Is it in here? Component group, which is literally that. Yeah, I'm probably not going to do that for now. So if it doesn't have any, we don't create it. If it does, we need to check. First of all, does it have a compound colliding component? Because if it does, then the way we add these shapes is going to be a bit different. Right? If it doesn't, we can just go and process the colliders like we would normally. But if it does, we need to grab it. Compound collider components. And I'm probably just going to write out the Jolt code here for now. So the idea is we need to include relation, shapes, compound shape, and mutable compound shape. So okay, compound shape is by default immutable. But static, mutable, compound. What's the difference? It's just that cannot be modified once the shape is constructed. So this one's immutable as well. It shifts all child objects so that they're centered around the center of mass. Okay. What about the regular compound shape? It's a base class for a compound shape. So my suspicion is you don't create this explicitly. You either use the mutable compound shape or the static compound shape, I suspect. Yeah, and this is optimized for adding, removing, and changing that, but it's less efficient in querying. Okay. Good. So, if is immutable, yeah. Otherwise, we do JPH. So if it's immutable, we do a static compound shape settings. Which takes what exactly? Nothing, you just call add shape. Alright, so you do compound shape settings, add shape. And then you add it in like that. Okay. Cool, cool. Whereas here you'd create a mutable compound shape settings, which is the exact same, but it's mutable. Okay. Cool, cool. Now, how do we actually go about doing this? So we need compound shape and immutable compound shape. And I assume for a static one, I can't change. I have to provide everything before I create the actual shape. Yeah, makes sense. So see, now here's where it becomes interesting, because we need to go through all of the entities that are in this vector. Yes. We need to also get scene somehow. So let's use scene, get scene, get scene UID. Try get entity with UID. Writer entity. If not, entity continue. What I may have up here is just a static vector. Physics shape. Create shapes for entity. And I'm definitely going to be refactoring all of this later on. You do not have to worry about that. Because this is essentially what we want this to be. This would, for example, call create shapes for entity, entity. Could just have this be... Oh, but you see, that introduces an interesting problem. I need to not have this be an array. Yeah, this would have to be a vector because now we can have multiple shapes of a single pie. We could have this be an array of vectors, possibly. Alright, so you can have an unlimited number of shapes for a given type. Not sure if that's great. I think, doesn't that kind of defeat the purpose of using an array though? For now I'll allow it. Because that means yes. I think I'm gonna do this instead. Jolt, rigid body. So we grab the scene, check if the entity has a compound collider component. If this entity isn't the entity that created this rigid body, we don't want to check for compound collider components. Well, we maybe do, but if this has that, then we just ignore it as long as it's not equal to M entity. Alright, so if this is the case, yeah, let's go up here and add that and entity not equal to M entity. Fail. Which, you know, we could reduce this a bit by just going if entity is not that return, which we don't want to do anything. Otherwise, we grab it. ID, entity. Okay, so if we have this, then we want to again. No, but you see, this isn't correct either. Because this will do this. So we can't call create shapes for entity. But I think this is better, because if we then do, you know, if I'm gonna change this, if this has component, box collider component, then we want to do compound shape settings. You know, dot add shape, and we presume we want to create the shape using this entity and then get the native one and add it like that. So collider entity. We could, of course, create the shape settings in this case, instead of creating the actual entire shape. What does this do? It does that. Figures out the collider size. And then just does that. Okay. So position, well, because if we've done this, then the positions should be 0, arguably, because we've already given the shape a kind of local position, I think. No, actually. Really doesn't have scalar structure. That's annoying. The shape. So we'll do a static cast like this. I think I can do that. And then at the end, we want to actually create it. Now, obviously, here's where the issue comes in that we store physics shapes, not build shapes. Which means this can't be this. Okay. Because I could create here some base files called compound shape, but it won't really apply to physics. Or will it? I mean, I guess it could, because it would just mean that we add the shapes to a single actor. Right, so this would just go through and create the shapes like normal. Yeah. So is this the immutable one? Yes. So let's maybe specifically call it immutable compound shape. Yeah. Now what I want for this is to have basically a virtual void add shape. The thing is, if you call this after you've created it, then it's gonna do an assert. Right, so this is because what I'm envisioning here is kind of going create immutable shape and then do shape add shape, right? We give it like the box shape, and then we do create, and that will actually go through and create the Jolt shape, at which point it would basically go ahead and prevent this from working later on. So shape add shape here would assert, because that way we don't have to, that way we can still do this after we've created the actual Hazel shape. And let this take care of everything for us. And in physics, this could literally just be like add shape, could literally just instantly add it to the actor. Shape create would simply set a flag that says don't allow us to add any shapes to this ever again, and we could still have it assert or something like that. Possibly. So we'll have add shape. It will be const physics shape. And then we'll have a virtual void create like that. Yeah, I like that. Well, I'm liking it so far at least. Jolt immutable compound shape. Taking the entity. Let's destroy. Made a shape. Which in Jolt's case will actually have a static compound shape, and will also include the immutable compound shape. Okay, let's implement that. Why wouldn't you create that above the box shape? Thing is, it's defined above it. So, immutable compound shape entity. And that's all this will do. right? No, it's not. This needs to hold DPH static compound shape settings. And this we'll call add shape. In the same way that this will. Get native shape. Right, so that's all this is gonna do. Then this will basically do this. If static compound shape. Really? Settings. It needs the allocator as well. Interesting. Why? So it grabs the number of shapes. It does it for the bounds. Oh, so does this construct it into a single shape? Effectively? Interesting. Okay, I mean I can do that. We can include Jolt API, then do physics API, get, no, let me start. Current. No, that's not it. We need the Jolt API as well as the physics system. Physics system here. Because we can do physics system get API, build API, and then from the API we can do get temp allocator here, which returns a pointer, and this expects a reference, of course it does. Okay. Immutable compound shape. Non-static shape. Cool. Progress. So then in here, what we would do is we wouldn't do this. We would do immutable compound shape. Compound shape. Takes in entity, I think. Yeah, that should be safe to do here. Then in here, we do this, but we will simply do compound shape dot add shape. That. Then down here we can do compound shape create. And Let's make this in an order map. It's so much easier to access the keys. Done. Compound shape. You would only ever have one compound shape though, I think. And just add that. Like as you would only have one compound shape per actor, because it doesn't make sense to have multiple compound shapes. That makes sense. Let's maybe only do this for immutable compound shapes for now. And this becomes box dot push back that. Oh, let's do entity here as well. Of course, if we get to this point, we should return. No. Yes. We should. Okay, I like that. Here we can do if shapes dot empty. We bail. And here we just need a shape, right? Let's maybe do shape type. Shape storage. Because literally all I want is first shape. Yeah. Right? And we can just do first shape. What is going on with this weird ass formatting? Shape storage. Literally just get the first possible shape and then fade out. There's probably a better way of writing this, I imagine. But whatever, it works. First shape. We do that. Can I add more shapes to this afterwards? No, which makes sense because you wouldn't want that, because if you have multiple shapes, you should use a compound shape. Exactly. Pixel, thank you so much for that subscription. Wow, that's awesome, man. Thanks a lot. I'm glad you enjoy my content enough to subscribe. Well, you're one of the first subs. I think you get the kind of founder thing if you are one of the first 10 or something. Thank you. This is definitely a bit dodgy. Maybe we... whatever, let's try it. Again, I think this is not strictly the best way of doing it, but whatever. If M shapes empty, bail out, don't create shit. This whole attached shape thing is gonna change quite a bit. First shape. It feels very different to be using this, to be using Jolt, because I'm so used to doing things a certain way in physics, and now with Jolt, it, like, the concepts doesn't really apply to Jolt. The way you do it is just so different that I'm actually having trouble kind of wrapping my head around, kind of imagining what it will end up being. Also, I'm probably gonna be taking like a little pause around in like maybe 20 minutes to have some dinner. But I'm probably gonna stream again once I've had dinner because I definitely want to keep working on this. Super fun. So I imagine I'll be starting up a stream again at around. Okay, what's this? Right, we changed that. So let's just do this for now. Push back the shape there. And I'll just do this. Let's do that. So yeah, I'm probably gonna head out in about 20 minutes. And then I'm gonna pop back the stream at around maybe 6 p.m. my time, so like an hour after I stop, maybe. Is this Jolt the same as Horizon Forbidden West uses? Yes, it is. They used Jolt because they wanted to move to an alternative. I don't know if they use PhysX or their own kind of proprietary one for Horizon Zero Dawn, but they wanted to move away from it. And Jolt was open source. It takes great advantage of multi-cores, and it's written in modern C++. So there's a lot of advantages to using it. That's not the thing we need. So yeah, it is the same Jolt. If we pop open the GitHub repo here, Jolt physics. we can see it's the same one. I wanted to watch the GDC talk that this guy had, but you need to pay a bunch of money to get access to it, which I'm not gonna do. Which is a shame, because it would have been very interesting to see what he had to say. Also, I think Guerrilla Games did a talk on why they switched to Jolt as well. But I probably can't get access to that. Come on, why aren't you launching? So yeah, I'd heard about Jolt like a couple of months ago actually, but I didn't really pay much attention to it. But then randomly, like I think 2 weeks ago, I decided to have a look at it, and it's super interesting. I'm really liking it so far. So if I add this as compound collider, then all of these should be compounded into this actor. Now, I don't know if this is gonna work for the box colliders. Let's save and hit play. That seems to work. Let's turn off the bloom here. Let's move that one and maybe move a cube over this one. Okay, simulate. Wow. Did that just work on the first go? Where am I? Here I am. See, now that's dodgy. Because I didn't hit that breakpoint. Wait, what? Okay, let's just see if we ever hit this. No, actually we wouldn't, because I'm not copying the components across. I'm not copying it here. Okay, good. Let's go into prefab as well and make sure to do it immediately. There we go. Let's see if it still works now that we actually use compound colliders. You go away. You go over. There. Bit more. There. Save that. Okay. Yes. Doesn't exist. Because time to ban another person here. Well, I say person, it's a bot. I was able to get away from those bots for a while, but now they're coming back. So annoying to start this up in debug mode. Thank you. Okay. Good. Oh, compounded collider entities has a size of 0. So does that mean that YAML cannot serialize that? Am I gonna have to do that manually? Probably. Okay, so how is it that we do sequences or like an array? So key, value, begin sequence, map, key, and map. Okay. Good. So let's do this and do begin sequence and sequence or constant reference the ID in that begin map and map good. Come down here, say that auto if no, if that, how do I deserialize it then? So children. We just do for auto, and then it's that ID as, okay. We do for auto child ID in that, and we do this, push back. That. This should now work, hopefully. Where do we have the hoop? We have it here, good. So remove it, add it, save. Now let's verify that that actually saved properly. And it seems to have done that, yes. Good. Let's hit simulate. Okay, so now it should be using the compounded collider components. So, put a breakpoint here. Simulate. Do that. We go through them. Okay, looking good. Yeah. We now have an immutable compound shape working. Awesome. And yeah. So I'm gonna go ahead and end the stream here, but I will be streaming again tonight, so keep an eye out if you want to see more of the Jolt development, so to speak. And yeah, thank you everyone for watching. Have a good night/day, and hopefully I'll see you next stream. Bye bye.